There. It's bright. Can't see anything. All right. So I'd say it was a really good test. Just as a whole, I think it was really good. So I'm really pleased to see where you guys are at. We'll just keep doing more. Let's do what we do, shall we? Yeah, that's a really good idea. Excellent idea. Oh, I face this way, so for me, it's all the same to me. Okay. Pull this up. Change this. Recording, good to go. So last day we started chapter 6. I had someone ask me about question 4 on that on the Moodle assignment I posted. You'll be able to do that one after today. That was my mistake. Shouldn't have snuck on there. It was late, I guess, when I made it. I don't know. But you'll be able to do question 4 after today. Okay, so I'll just make a note of that. You will be able to do question 4. Is it on assignment, is it 10, the latest one? 10, yeah. On Moodle assignment 10. After today. Okay. So make sure you squeeze that one in. The reason you can't do it quite yet is because last day we only talked about, okay, so we have annuities. Remember, annuities are when we have regular payments coming in or going out, right? We're making payments or we're getting payments, right? So we, just as a quick review, or kind of a long review, we talked about annuities, and that's when we have regular payments. Oh, regular. Oops. Regular payments. Coming in or going out. Right, so think about car payments, mortgage payments. Usually it's money going out until we retire, right? When we retire, we get money at regular intervals, right? Mortgage or your pension. So you get these payments at some payment frequency, right? And so payments happen at some payment frequency, which we denote by P of Y, or P/Y. Doesn't look very clean, does it? Payments per year. Payments per year. Okay. So before, right, we only dealt with the compoundings per year. What was your compounding frequency? Okay. So now we've got payment frequencies and compounding frequencies that we have to think about. Okay. The thing is, our formulas can only handle one frequency, right? So what we're going to start looking at today is, what do we do when the payment frequency is not the same as the compounding frequency? Right? And so last day, we said, we looked at finding the future value and present value. when the compounding frequency and the payment frequency were the same. When the compoundings per year and payments per year were the same. Today, we're going to look at, well, what do we do when they're different? And we said, okay, we've got this future value formula on our formula sheet. Don't have it memorized quite yet. I will, but have to use it enough times. So now we're on the back page of your formula sheet, right? And so we're talking about annuities. And on the left-hand side, we're going to have just regular, ordinary annuities. And then on the right-hand side, we've got annuities due. The only difference between these two is the first column is when the payments are being made at the end of the month or the end of the day, the end of the week, right? Whereas annuities due, the payments are being made at the beginning of the month, beginning of the day, beginning of the week, right? So we're going to have to differentiate when the payments are being made. But we don't get into that until chapter 7, right? So we'll start that next day. But the ideas are all the same. Okay? And so we developed this future value formula, which takes the payment amount, right, which is your PMT. So that's the regular payment amount, right? Your mortgage payment, your car payment, that's your PMT, times 1 plus I to the power of n, all minus 1 over I. Same idea. If we want the present value, notice how the future value doesn't have a present value in it like we're used to, right? We've got these two separate formulas. And the idea is, well, if you're calculating a present value, right, then you're making payments to pay off some loan, typically, right? And so when you're done paying it off, the future value is 0, so it's gone, right? If you're saving money, right, putting money into the bank every month, then you start with nothing and you end up with some future value, right? So you only have one or the other. And so that's why we have these two different formulas. So we've got the present values, the PMT starts the same way, but then we have 1 minus 1 plus I to the negative n all over I. So that's kind of where we got to. Oh, and also, we also learned how to find the periodic interest rate from some compounding frequency F1, converting it to some compounding frequency F2. Okay? So how to find the new periodic interest rate when converting from a compounding frequency F1, compounding frequency F subscript 1, just to denote that's your initial compounding frequency, and we're converting it to some new compounding frequency F2. So converting from a compounding frequency F1 to a new compounding frequency F2. And we use the formula, right? We went through all those I formulas at the top of the second page, right? But really the only one that we need to know, or use rather, is I2 is 1 plus I1 to the power of F1 over F2, all minus 1. Okay. So we covered a lot of ground last day, but today we're just going to keep talking about all that stuff. Right, so just keep working at it with a twist. Okay. Where am I here? Here. Any questions about last day? No. So we'll start with 6.3, where we have to calculate the periodic payment, so PMT, and then how do we calculate M, right? Same idea as before, where we just go through, we get a new formula and we just rework it and we try to solve for all the things that we can solve for in there, right? Just so we get to know the formula a little bit better. So here we're going to be calculating the periodic payment, which is your PMT, and number of payments, which is N. Still. Notice in these formulas, right, we have everything that we need. So it's just going to depend on, do we know the future value or do we know the present value? Depending on which one we know, right, we'll be able to solve for PMT out of one of those formulas. Okay. So we'll start with solving for PMT. If we know the future value, so if we know the future value, plug in all the given values into the future value is the PMT times 1 plus I to the power of N minus 1 over I, and then solve for PMT, and then solve for PMT. So if I'm asking you to solve for the payment amount, I have to give you the future value. I have to give you, well, usually the rate and the compounding frequency, right? And then you can calculate I. And also, I have to give you time and the compounding frequency so that you can find N. Right? And so you'll have all that information, and then you can just solve for PMT. Okay. Of course, if we only know the present value, then we use the present value formula, but the same idea applies, right? We plug in all the values. I have to give you all those values, and then you have to solve for PMT. Okay. And so I'll just say it here. If we only know the present value, we only know the PV, we use PV as the PMT times 1 minus 1 plus I to the negative N over I. And then solve for PMT after substituting in all given values. Let's look at an example just to see what's going on here. We'll do example 212. So like I said, we're either making payments to save for some future value, or we're making payments to pay off some present value. Right? So your RRSP goal is $300,000. The current interest rate for RRSPs is 8% per year compounded annually, and you intend to retire in 30 years. How large should your year-end contributions be? Okay. So let's highlight some information that we're given here. So we have to look at, okay, what's our compounding frequency? Our compounding frequency is 1, right, annually. And then we're going to make year-end contributions, right? So at the end of each year, we're going to make contributions. So our payments per year is also 1, right? Good thing, because that's the only thing we know how to deal with so far. You can probably figure it out, but so far we've only talked about where our compoundings per year and our payments per year are the same. Right? But today we'll introduce, well, what do we do if they're not the same? Right? It just adds one more step, but then it's back to the same step. Okay? So here, good, they're the same, so we can keep going. And we've got R is 0.08. Here, our savings goal, that's in the future, right, is 300,000. So this is going to be our future value. And we want to find our payment amount, right? How large should these payments be? So we can start by making a timeline just to get an idea of these things, but also to get used to drawing timelines for these annuities, right? I said I want to have at least 3 ticks at the start and at least 2 ticks at the end, right? So it's going to look something like this. So here I'm starting today, and I'm making payments for 30 years. 3 ticks at the front, today 1, 2, 3, and then 2 ticks at the back, 30 years, 29 years. Today 1 year and 2 years, and then ... in between, right? Because the same thing happens every year, so we don't have to draw them out. Okay. But like I said, so I want to see 3 at the front at least, and 2 at the back at least. So now, we don't know these payment amounts, but that's what we're trying to solve for. So what we're going to do is we're going to put our PMT down here. So we make a payment at the end of this year, and then a payment at the end of the next year. And then, so underneath all these, we've got payments. Right, some payment amount PMT. Remember how we indicated that all of these payments are going to funnel to some future value, right? So I do this, or if you want to just do straight brackets, that's fine too. I like curly brackets. I think they're fun, so why not? So then here, what I do is I take this kind of funnel and I say, okay, well, that's going to become this future value. And so the future value, oh, I think I drew my arrow a little bit too long here because I have to have room for 300,000. Not quite fitting on there, but well. Remember the difference between the usual compound interest problems that we're dealing with and now annuities? N is now going to be the number of payments, right? So N is T times F, where F is the payments per year, which is 1. Which is going to be, time is 30 times 1. So we just have N of 30. Even if we were talking compoundings in this case, because they're the same, it doesn't matter. Right? But later on, we're going to have to make sure that it's going to be the number of payments that we're making. Okay. So now we've got all this information mapped out on a timeline. And so we can go ahead and, well, I guess I should figure out what I is somewhere around here. I is R over F. R was 0.08 divided by 1, which is 0.08. Surprise. So now we look at this and say, okay, well, since I know the future value, I have to use the future value formula, right? I know I and I know N, which means I can plug all those values in and I can solve for PMT. So I don't need a new formula for that. I can just use the old one. So we've got the future value is the PMT, which we're trying to solve for, times 1 plus I to the power of N minus 1 over I. My future value is 300,000. Again, I'm trying to solve for PMT here. And so I leave that, and then 1 plus I, which is 0.08, to the power of N, which is 30, minus 1 over I, which is 0.08. Clean up this one. So we're going to get really good at calculating these big brackets, right? Because we do the same thing always. You start inside the little brackets, find the power, and then in this case, subtract 1, right? And then divide by I. Right? So it's always the same procedure. And what you'll find is that it's almost easier to just go from here to the final answer, right, without jotting down any of the steps in between, and that's fine. I'm going to do that actually because it's hard to stop and jot down your work. So we've got 300,000 on this side, that stays the same. PMT is there, but then, so what I do is 1.08, right, 1 plus 0.08 to the power of 30 minus 1 divided by 0.08. I get 113.28321111. You can either store that, right, because you don't want to have to type that out again, so you can store it. I'll store it in 1. And then we're going to solve for the payment amount. The payment amount, right, is going to be the 300,000 divided by 113 point whatever. So 300,000 divided by 113.2832111 divided by recall 1. Each payment has to be 2,648.2 230016. In terms of money, we have to round money to 2 decimal places, right? So we get $2,648.23. You would do the exact same thing if you had the present value. So what I'm going to do, we're not going to do it together. I'm just going to say, see example 213 for an example using PV instead of FV. Just because it's the same and we've got bigger fish to fry. Any questions about that one? Okay. All right. Then we will talk about calculating the number of payments. The number of payments, which is just calculating N. On your formula sheet, the reason it's so big on this side is because, well, we have to have 2 formulas, one for if we know the future value and one for if we know the present value or want to. And then we've got 2 formulas for N. But if you look at them, they're very, very similar, right? And again, the only difference is, do we know the future value or do we know the present value, right? That's the only difference between the two in terms of the information that we know, right? And so all that covers 2 more formulas on here, right? Taking up a lot of room, but it's just, we need 2 formulas. So if we know the future value, we use N is the log, so the natural log of 1 plus I times the future value over the payment amount over the log of 1 plus I. Yeah. Doesn't look like PMT, does it? Dunno. Okay. So there's the future value, but you'll see it on your formula sheet. Right. But it's hard to see the future value versus the present value on here, right? But that's the only difference between these 2. So this is on your formula sheet. And then same idea, right? If we know the present value, we use N is the negative log. So don't forget that negative. The negative log of 1 minus I times the present value over PMT. See if I can. Doesn't look that good still. Over the log of 1 plus I. And this one's also on your formula sheet. And I've just circled the PB because that's the only difference. There's some negatives in there, some minusing, but all the information that you need is in there, right? We need I, we need PMT, and we need either the future value or the present value. We'll never have both. Okay. Let's look at an example, because what's N? N is the number of payments, right? But just as before, when we were calculating N, the end goal was to find how long is this going to take, right? And so N in this case is going to help us figure out, well, how long do we need to be saving for to get some future value or to pay off some present value? So let's have a look at example 216. Uh-oh. Maxwell borrowed $20,000 from loan shark Alec. Sounds bad. Alec demanded year-end payments of $3,500. How long will it take to pay off the borrowed money if Alec charges 17% interest compounded annually? So just to get in the habit, let's talk about, okay, so we're making year-end payments. So our payments per year is 1. And interest compounded annually, so our compoundings per year is 1. Again, so far, we only know what to do when they're the same, right? We're about to talk about what to do when they're not the same. But for now, yeah, good, they're the same. And so here, this 20,000, he borrowed 20,000 and now he has to pay it off with these payments, right? And so the 20,000 is your present value. We've got a rate of 17%. And also our PMT is 3,500, right? Each payment that we make each year is $3,500. How long is that going to take to pay off then? So we know the present value, and so we have to use the N that uses the present value, right? By the time, so if you think about it this way, if he's paid off the loan, which is in the future value is 0, right? There's nothing left owing. And so we use N is the negative log of 1 plus, or sorry, not 1, it's 1 minus I times the present value over PMT over the log of 1 plus I. Is the formula we're going to use. Okay. We could just jump into it. How about we draw the timeline just for practice? We don't actually need to. We know we can figure out I, we know the present value, we know PMT, so we don't actually need to draw a timeline, but it's good to kind of get some practice in. And so I'll just make a note here. We will use, since we know PB. Let's just practice drawing the timeline. So again, we'll start today and we want to go for N years, right? We're trying to solve for N. How long is it going to take? because our payments are being made each year, right, we're going to be able to find how many payments we need, right? But also that's going to be the same as the years. We'll still treat it as n though and try to solve for t. But it's going to be n years. And so 2 ticks at the back, so n minus 1 years today, and then 1 year later, and then 2 years, ... Each year, at the end of each year, I'm making a payment of 3,500, 3,500, 3,500, and 3,500. All of these payments are going to funnel in to pay off some present value of $20,000. Okay. So these guys are all going to funnel in to pay off $20,000. I'll just say n equals question mark here. And I is r over f, which is 0.17 over 1, which is 0.17. Let's use so there's your timeline. A little bit different, but I mean, in theory, you could draw 30 ticks, draw all of those arrows, calculate 30 present values, make sure they add up to 20,000, but that feels like a lot of work, right, that you don't have to do. But you would end up at the same value. So n, what we said was the negative log of 1 minus I times the present value over the PMT over the log of 1 plus I. Now we know these values, so we can just plug them in. So we get the negative log of 1 minus I, which is 0.17, times the present value, which is 20,000, over PMT, which is 3,500, all over the log of 1 plus I, which is 0.17. So let's see here. I'll start with the log on the top. So I'm going to do 20,000 divided by 3,500 and then times it by 0.17, right? I have to deal with that lump first. Order doesn't matter because we're just multiplying and dividing, right? They're on the same level. And so we do, oh, come on. I'll charge it while I'm calculating. 20,000 divided by 3,500 and then times 0.17. I get 0.97, blah, 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 blah. Yeah. I have to do 1 minus that. Okay. On your calculator, you've got if the second and then the answer button is above the equal sign. So I use that quite a bit where it just, we can plug in the last answer that it gave us, right? So we don't have to store it all the time. You can, but if I just do 1 minus and then second equals to get the previous answer, and then equals again, I get 0.028571492, or sorry, 29. That's all I'm going to be able to charge it. So I get the negative log, just to check in, I have to take the negative log of 0.028571429 over the log of 1.17. To take the log, right, you just have whatever you want to take the log of on your screen and then hit the ln button. So I get negative 3.555348061. 555. It's like a mix of the Backstreet Boys and Five. Does anyone remember Five? The band. Come on, guys. They were one-hit wonders. But anyways, I am going to store this negative 3.555. Store it in one. And then I'm going to find the log of 1.17. And so I have to have 1.17 on the screen, and then I hit the LN button, and I find that it is going to be 0.157003749. I'll store that in two just in case. The negative of a negative just makes it positive, right? And so that's why we have that negative there, because in this case, we're always going to get a negative value out of the log. And so the negative is just there to get rid of the negative. So it's not actually doing anything. But what we have is recall 1, and then negative that divided by recall 2. I get 22. Let me just check that. Yeah, 22.644988834. Remember the rule when we were finding n? Doesn't matter what the decimal is, we always have to round up, right? Because what we're saying is, okay, we need 22.6 payments. If we went only and did 22 payments, we're not quite paid off. Right? So we have to make 23 payments. Yeah. And so since we can't make partial payments, we will need to make n equal to 23 payments. So you have to use 23 in your calculations. Remember, n is time times the frequency, but because n is the number of payments, f has to be the frequency of the payments. Right, they have to match in order for us to be able to solve for t. In our case, they're the same, right? But later on, they won't be. The payment frequency and the compounding frequency won't be the same. So what we have is we've got 23 is time, which we're trying to solve for, times the frequency, which is just 1. So t is 23 years. Yikes. If we think about it this way, so 23 years, that's a very long time to be paying off $20,000, bless you. But how much is it actually going to cost them to borrow these $20,000, right? Because he's making 23 payments of $3,500, right? And so how much will it cost him to borrow the $20,000 in the end? Well, he's making 23 payments of $3,500. 23 times 3,500. It's going to cost them $80,500 total. That's a lot. and take them a long time to do it too. How much interest will he pay? Well, the total is the present value, that's the loan amount, plus the interest. So we said 80,500 is 20,000, and all the rest is interest. I. Didn't actually need to use my calculator, I don't know. Sometimes I just get caught up in it. He's going to pay $60,500 in interest. It's not good, but that's what it is. Right? And so we can get a lot of information out of this. Right? We can figure out, okay, well, how much is he going to have to pay in total? How much of that is interest? Right? So, any questions about that? Okay. Where am I? All right. Oh, let's do 6.4 then. 6.4 is about ordinary general annuities. And so we were talking about simple annuities where the compounding frequency and the payment frequencies are the same. Now we're going to talk about what happens when they're not the same. Not that much, actually. We just have to change our compounding frequency to match the payment frequency. And then we're back to where we were, right, just now. And so 6.4 is on ordinary general annuities. What makes them ordinary is that the payments are being made at the end of the payment period. Payments at the end of the payment period. In chapter 7, we'll talk about annuities due. So there's ordinary annuities and annuities due. Annuities due are the ones where the payments are at the beginning. Again, we just make a little shift and then nothing changes. Right? So it's just a little change that we make and then everything stays the same. But for now, we've just got payments at the end of the payment period. Okay. And general is when the payment frequency is not the same as the compounding frequency. So when the payment frequency payments per year is not the same as the compounding frequency, compoundings per year. So that's why we were practicing when we were reading those questions, right? To highlight, okay, what's my payments per year and what are my compoundings per year? And we were just checking to make sure they were the same. Now they're not going to be the same, so we have to have that added step of adjusting our interest rate. So when the compounding frequency is not the same as the payment frequency, we adjust it to be the same as the payment frequency. So when the compounding frequency is not the same as the payment frequency, we change the compounding frequency to match the payment frequency. We change the compounding frequency to match the payment frequency. So we're going to start with some compounding frequency. That's going to be your F1. And then we want to go to some payment frequency. So the payments per year is going to be your F2. To convert from F1 to F2, use I2 is 1 plus I1 to the power of F1 over F2 minus 1. Once you have your I2, now you're back to where we were just a minute ago, right? Now you've adjusted your compounding frequency to be the same as your payment frequency. So now you just apply the same formulas as before, right? So after finding I2, we use I2 as our I, and use the same formulas we were using earlier. From now on, I want you to try to calculate I2 for every question. That's the safest way to do it, right? Because what's going to happen if F1 is the same as F2, right? What's the worst thing that can happen? What happens if F1 equals F2? Well, I2 is 1 plus I1 to the power of F1 over F2 minus 1. If F1 and F2 are the same, right? 4 divided by 4 is 1, 3 divided by 3 is 1, right? So regardless, F1 over F2 is going to be 1. So then we get is 1 plus I1 to the power of 1 minus 1. The power of 1 is going to go away. So then we have 1 plus I1 minus 1. So then what we land at is that, well, I2 is just going to be equal to I1. Oops, I2. So there's really no harm in always trying to find I2 at the start of every annuity problem, because if you have to change it, then you will, right? If you don't have to change it, well, yeah, you did a little bit of extra math, but not that big of a deal, right? it's way worse to not have found I2 when you should have. Right? And so from now on, I recommend that you always start by finding I2 when doing annuity questions. It's just a good rule of thumb. From here on out, we're just always going to try to calculate it. Sometimes we won't need to, but most likely we'll have to. All right. Let's do an example. Let's do example 218. Any questions though before we do? No. All right. Let's see what we've got going on here. Suppose month-end payments. So now we're making monthly payments. So I'm just going to jot that down as our payments per year is 12, right? Monthly. Bless you, bless you. Of $300. So our PMT, right? Our payment amount is 300. Are made on a car for 4 years. So T is 4. The rate of interest is R is 0.05 per year compounded quarterly. So our compoundings per year is 4. What's the value of the car? Okay, so we're making payments to pay off the car, right? And so the value of the car is going to be the present value. Because we're not putting in $300 and saving it to go buy a car, right? We've bought a car and now we're making payments to try to pay it off. And so here, that's what makes it the present value is what? Or I should say equals what? Let's translate this question into a timeline just so we can see what's going on. And so here, we'll start today. And 1 month later, I make a payment. So here I'm at 1 month. I'm just going to use M's for months, right? Because we're going to do a lot of them. So 1 month and then 2 months. And then for 4 years, right? Up above a little bit, I'll put the 4 years, and then below it, I'll put how many months that is. Because I've got 4 times 12 is 48 months. Then I'll be done paying it off. And then the payment before that is at 47 months. ... in between. Right? 3 at the start, 2 at the end, ... in between. We put the payment amounts below, and so each tick is going to have 300. There's no payment being made today because I'm paying at the end of each month. Right? Later on, when in chapter 7, when we move to making payments at the beginning of each month, then we would start today. But this is how we show on our timeline when the payments are being made. So we've got payments of 300, 300, 300, and 300. And these are all funneling in to some unknown present value. We actually already found that n is time times the frequency of the payments, which is going to be 4 years times 12, which we already found was 48. Here's where I'm going to make a note. My payments per year is 12, and my compoundings per year were 4. Payments per year is not equal to the compoundings per year. So we must calculate I2. But like I said, for us, what we're going to start doing is we're always going to calculate I2. Sometimes we won't have to do it, right? But it's always good to just always do it. We're moving from the compounding frequency to the payment frequency, right? Making this compounding frequency is the F1, and the payment frequency is going to be F2 in our calculation. I should have left a little bit more room there. Next one. I2. Oh, I guess we need I1 first. You can do it inside the formula, but I like to do them piecewise, so there's not so much going on in each formula, but that's just my preference. If you want to calculate I inside there, you can. I1 is R over F1, which is, our rate was 0.05 divided by 4. So you find your I1 the same way that we've been calculating I, right? R over F, 0.05 divided by 4, 0.0125. Now I can change this, right, from being compounded quarterly to being compounded monthly to match the payment frequency. So I2 is going to be 1 plus, plus I1, bless you, to the power of F1 over F2 minus 1. That's going to be 1 plus 0.0125 to the power of F1, which is 4, divided by F2, which is 12. Right? Going from quarterly to monthly, minus 1. We have to solve inside the brackets first, then do the power, then subtract 1. So I get 0.0125 plus 1 to the power of, and just to be safe, I'm going to put my 4 over 12 in brackets just to play it safe. So to the power of, and then bracket 4 divided by 12, end bracket equals, just to jot it down, I get 1.004149425. Don't forget that minus 1 though. As soon as you see, and remember I is the amount of interest that you have to, or that, yeah, that you are paying per month. 100% interest is a little bit bad, right? So you have to remember the minus 1. So now our monthly interest, or the amount of interest per month, is 0.0041494425. Once you have that, we're going to use that in our calculations a lot, right? So you're going to want to store this. So I'll store it in one. Okay. What we've done so far is we've adjusted so that our compounding frequency is the same as our payment frequency, right? So now we're back to where we were, and we can just use I2 as our I, and we can calculate the present value. So now we use I2 as our I and calculate the present value, sorry, PV. From our formula sheet, we know PV is the payment amount times 1 minus 1 plus I to the negative n all over I. We know our payment amount is 300, plug that in, times 1 minus 1 plus I, which is 0.0041494425 to the power of negative n. We already calculated n as 48. So to the power of negative 48, squeezing it in there, just all over I, which is 0.0041494425 again. If you want to, you've told me that you've stored this in one. If you don't want to write it out in the formula, what you can do is you can say, or you may write equals 300 times 1 minus 1 plus store 1 to the power of negative 48 over store 1. As long as you've shown it before, right, as long as you've shown this up there, saves you a little bit of writing. I don't know how you like it, but saves a little bit. As long as you have told me what is in store 1. It's kind of a side note, I guess, in the middle of our notes, but oh well. So jumping in there again, right? I start inside my little brackets and I slowly balloon out, right? And so I've got 1 plus recall 1 to the power of 48 negative equals 1 minus that divided by recall 1. I guess technically, shouldn't I say recall 1? Now that I'm thinking about it, I'll know what you mean. Either way. I usually just end up writing out the whole value. Doesn't matter. Yeah, technically we should say recall one. Anyways. Anyhoodle. I get 43.44. Hopefully I did it right. I'll just check times 300. Yeah. So just to check in here, I get 300 times 43.44063287. If you skipped straight to the final answer, that's fine. I'm just showing so you can check your work. Times 300 is 13,032.18986 in money. Oops, that's going to be 13,032.19. What are we even answering? Oh yeah. How much was the car worth? Right. So that means we got a loan for $13,032.19. All the way here. Therefore, the value of the car is 13,032.19. Nice. Yeah. We can do this problem on our calculator. What's nice about doing it on your calculator is it'll take care of finding I2, right? Because remember when we use our calculator, we had to tell it what the payments per year and the compoundings per year were. So if it notices that they're different, it'll just make the adjustments for you, okay? And so it saves that. But to make things fair, because on test 3 and on the final exam, you can either show your work like this, show all your work by hand, or use your calculator. It's fine by me. Okay. They're worth the same. And so for some of these, maybe use your calculator because it's going to be a lot faster, right? But for the long answer problems, I always want to see your I2 calculation, even if you're using your calculator, just to make it fair. Otherwise, it's not fair. Okay. So we can solve annuities on our calculator. Some notes that you might remember is that what we're going to use is that money leaving our hands is going to be negative and money coming to us is going to be positive. So money leaving our hands will be negative, and money coming to us will be positive. This is going to be important now because whether we're making payments to pay off a loan, right, or somehow we got a loan and we're also getting money each month, that doesn't really make sense, right? And so if we get a loan, that's positive, but then to pay it back, we make negative payments. And Also remember that, so I'll make this note number 1 and this note number 2, PV and FV must have opposite signs. So in the simplest terms, we either deposit some money and then at the end, when it's done growing, we take it out, right? Or we borrow some money and then in the end, we've paid it all back. So on our calculator, just moving from left to right across the white buttons, we've got N, which is the number of payments now. We've got the interest per year, which is the nominal rate. For 7%, use 7, not 0.07. And so you just use the number. Next one is our present value. That's our PV. Now, we will have PMTs, right? This is your periodic payment. Periodic payment amount. The future value is the future value. And we need our payments per year. So this is our payment frequency. And our compoundings per year is our compounding frequency. Let's do the question that we just did, but on our calculator instead. I suspect you're already kind of doing it. Saw some people working there, right? But let's do example 218 on our calculators. Because we've done the timeline already and we know the answer, so we can check to make sure that we did the right thing. So we're going to fill in N and interest per year, present value, PMT, future value, payments per year, and compoundings per year. We're trying to solve for our present value. So what I'm going to do, right, to indicate that is I put a star by it. Okay. We know N is 48. We already calculated that. We're told that the interest is 5%, so we just use 5. Our payment amount, and so these are payments that we're making to pay off this loan. So we have to make negative $300 payments. So negative 300, just because we are making payments. We're not getting these payments. Congratulations, you got a loan. Here's some more money. No, it doesn't work that way. Future value, though, when we've paid off this loan, has to be 0, right? In the end, we're hoping to be done with this loan, this debt, and so this future value is going to be 0. We're making monthly payments, so our payments per year is 12, and our compoundings per year is 4. So now, might not be too familiar with using your calculator yet, but you will be. So for these white buttons, we just put in the number 48 into n, and then it should just say n equals 48, and then you move on. So, and then 5 into the interest per year. And Antonio showed me the other day, there is a way that you can go back and check. You just have to read the manual, I guess. Who knew, right? Was it recall? If you hit recall n, it'll tell you what's stored in there, right? So if you're ever not sure what was in there, then you can hit recall and that button. So we've filled in n and I, interest per year. I'm going to leave the present value because I'm about to solve for it later. And negative 300, important that it's negative though, into my PMT, 0 into the future value. And then the second, over the interest per year button, you've got the payments per year. So second, to get the payments per year, 12. It's not going to store until you hit enter. So you have to hit enter, and then it should say payments per year equals 12. Otherwise, it's not stored. And then you can scroll down using the down arrow. The compoundings per year, now I'm going to change it to 4, enter. And then I can exit out of there. Once I have those in there, I can go and hit compute present value, and wouldn't you know it, I get a present value of 13,032.18986. Sounds familiar. So you get the exact same thing, but you didn't have to solve for I2, and you didn't have to really do any math at all. Nice. So let's do the same thing with example 219. First, we'll do it by hand, then we'll do it on our calculator just to make sure that things are matching up. Any questions about this one though? Oh, yeah.
If you're trying to solve, you had TV and it was money,
yeah. Yeah. So it just depends on where the money's going, whether it's positive or negative. So example 219. Oh, what the? Tom and Delilah wish to start a college fund for their daughter. How nice. Their goal is to put $200 into the account at the end of each 2-week period, right? So bi-weekly. Assuming that college fund will earn a rate of interest of 3.75% compounded quarterly, how much will be in the account in 20 years? Right? So we're making regular payments for 20 years. How much are we going to have in there? So that's going to be some future value, right? But first, let's just read through this and see what we've got. So we've got 200. Our PMT is 200. At the end of each 2-week period, so our payments per year is 26. R is 0.0375, and compounded quarterly, whoopsies, didn't leave myself enough room. Got arrows going like this, yikes. So my compoundings per year is 4. And T is 20. I'm going to start by drawing my timeline, right? See what's going on here. And so I'll start down here. Oops. So I'll start today. And then we've got 2 weeks. But you know what I'm going to do? Every 2 weeks is bi-weekly. And so what I'm going to do is I'm going to say, well, 26 is bi-weekly, which I'll call BW. So 1 bi-weekly, 2 bi-weekly. And the reason I'm doing that is because otherwise we have to figure out the number of payments, but then also if we were to just go with 2 weeks, 4 weeks, right, it gets messy up here at the end, right? And we just want to talk about how many payments do we have to make. And so in 20 years, with 26 payments a year, we're going to be at 520 bi-weeklies for 20 years. Now what's nice is we can just go down 1 to 521, yikes, 519. I say down, but I went up for some reason. 3 dots in between. So what you'll want to do is, just to make life easier, each of your ticks is just going to be the payment frequency, right? Every time you make a payment, you make a tick, right? And then whatever you find easier to put at the top, just do that. Okay? Whether that be 1 bi-weekly or 2 weeks, 4 weeks. $1,040 weeks, couldn't do that in my head, and then 1,038 weeks, right? It doesn't matter as long as you're consistent and it makes sense to you. But each bi-weekly, we're adding $200 to the account. These are all going to funnel into some future value that we're going to calculate. N is time times the frequency, which is 20 times 26, which we already found was 520. I1 is R over F. Our rate was 0.0375 divided by compounded quarterly, so 4. 0.009375. I'll actually store this because I'm lazy and I don't want to type that in again. My compounding frequency and my payment frequencies are not the same, right? And so I'm going to make a note. Oh, what the? There. My payment frequency is 26, which is my F2. And my compounding frequency is 4, which is my F1. That's always going to be the case, right? Your compounding frequency is your F1, and then you have to change it to match the payment frequency, which is going to be your F2. And so I2 is 1 plus I1 to the power of F1 over F2 minus 1, which is going to be 1 plus 0.009375 to the power of 4 divided by 26 minus 1. And if you just go straight to the end, that's fine. So plus 1. 1.009375 to the power of, and I just put it in brackets just to be safe, bracket 4 divided by 26 end bracket equals minus 1. 0.00143662. This one I'm definitely going to store. I'll store it in one. I don't need the old one again. All right. Now we've got our I that we can use. So now we can just use our future value formula and say, well, our future value formula on our formula sheet is the PMT times 1 plus I to the power of n minus 1 all over I. We were making payments of $200 times 1 plus, and here if you wanted to write recall 1, that's fine, but I'm going to write it all out. 0.00143662 to the power of n, which we found was 520, minus 1 all over I, which is 0.00143662. Start inside the little brackets and then bubble out. So plus 1 to the power of 520 minus 1 divided by recall 1 times 200. I get 23,000. Let me just check that I did that right. I didn't. 23,000. It must have gone astray. 1 plus recall 1 to the power of 520 minus 1 divided by recall 1 times 200. Now I've got two very different answers. So far, between just my work, I've landed on 3 different answers. One here, 1 plus I to the power of n minus 1 over I. Oh, oops. I didn't store my I2. I'm using the old I1. Oopsies. Okay. What was it? 4 divided by 26. That'll do it. Now store in 1. Phew. Plus 1 to the power of 520 minus 1 divided by recall 1. Okay. Just to check in, I get 200 times 772, which is what I have on my sheet too, 0.380111. So times 200, they're gonna have $154,476.0202. So in money, that's 154,476 and 2 pennies. What if we had to do this on our calculator instead? So, or on our calculator, we have to fill in N, interest per year, present value, PMT, future value, payments per year, and compoundings per year. We said we have 520 payments. The interest per year is 3.75. The present value, they're starting with nothing, right? And then it's going to grow to something. And so our present value is 0. Payments are 200. Are they positive or negative though? They're going to be negative, right? Because they're making payments into this account, right? So we have to make it negative. We're solving for the future value, so I'm going to put a star there. Just ignore it for now. And my payments per year were 26. And my compoundings per year were 4. All right. Now that we have all these things filled in, we can plug them in. So we get 520 as our N, 3.75 as our interest, 0 as our present value, 200 negative as our payment amount. What the? 26 payments per year, enter. 4 compoundings per year, enter. And now I'm ready to compute the future value. Good thing. I get the future value is 476.0202. Nice. Yeah. Oh, hit CPT and then FV. Not getting it? Is it not giving it to you? Yeah. Can have a look. All right. Any other questions? So make sure you do a couple. Maybe do it by hand first, then check it with your calculator just to make sure that you're getting the right answers. Okay. But we'll just start next day reviewing, and I'm going to throw a little curveball where we have some present value in there already, and then we're adding on payments, but nothing really changes. Okay. So I'll see you guys on Wednesday. If you didn't grab your test yet, come and grab them.